Hi everyone, welcome to Snetly. Today we are going to see about logical modules in the Snetly library browser. Okay, these are the logical modules. Now we are going to see one by one. Okay, first minimum and maximum. Okay, to see the output and input, we are going to take a constant for input and display for the output. Now just right click to see assign the values in the constant 2 and 4. Okay, back to semantic and just connect the input to A and B and output from the minimum of A and B and maximum of A and B. Okay, just run to see the output. Okay, you can see the minimum value as 2 and maximum value as 4. Okay, this is simple minimum and maximum value finder. Okay, next comparator. Okay, this is the comparator block. Okay, we can give one more value as 6. Okay, now in the carrier I am going to give the value 2 and here you can see this is the carrier and 3 inputs and we have 6 number of outputs, that means 6 various calculations. Okay, I'm going to give the 4 to the carrier 1. Okay, now output to the display. You can see here 1 greater than or equal to, that means 1 means 4 is greater than or equal to 2. Yes, this is true, then we can get the answer as 1. And 1 less than or equal to, that means 4 is less than or equal to 2. This is false, 4 is not less than 2, so we get the answer as 0. This is a simple comparator block. You can compare 3 input at the same time also. We can give the value 2, another one is 3. We can compare different calculation at the same time also. Okay, next, this is 2 input multiple output comparator block. Sorry, just delete the outputs. One more thing, you can see here, if I keep the block like this, you can see the error message here. That is space limits detected on the net visibility, please adjust the block position, because we need a considerable space between two blocks to connect the roots. So here we get the error message, so we just need to adjust the block to connect the roots. Okay, fine, just delete the blocks or nets and we can give the input A and B. Okay, here A input is 2 and B input is 4. We can perform all the operation at the same time. Okay, here it will compare between A and B, that means 2 greater than 2 equal to 4. No, it's not true, then 0. 2, that means A not equal to 4, that is true, then we get the output as 1. Likewise, A less than 4, A less than, that means 2 less than 4, 2 less than or equal to 4, 2 greater than 4, we get the output as the similar way. Okay, fine. Okay, next we going to take a 4 channel comparator. Okay, here we have 8 number of inputs and 8 number of outputs. Just right click to see the configurations. Here you can see the models execute compare operation for 4 channel. The input data types are IEEE 754 floating point format and A1 and B1 channels are compared and the output assigned to 1 and 1 less than or equal to 1. That means a1 and b1 is for this 1 and 1, 1 less than or equal to 1 and 1 greater than 1, and a2 and b2 is for 2, a3 and b3 is for 3, and a4 and b4 is for 4, likewise. Okay, just back to schematic. I am going to give the input for a1 and b1 and output from the 1. Okay, now you can see here a1 is less than or equal to 4. Yes, it is true. That means a1 means 2, 2 is less than or equal to 4. Okay, 2 is less than or equal to 4, that is true. And you can see 1 greater than, that means a1, 2 is greater than or equal to 4, 2 is not greater than 4, so it is false, so we get the value as 0. Okay, that's all for this block. Next logic gates. Okay, fine. Just right click to see the configurations. Here we have 4 inputs and 8 outputs. For the command values are from 1 to 7, and the functions are NOT gate, NAND, or NOR, AND, OR, XOR, and XNOR. For NOT gate, we can assign the input as A, C, likewise A, C, E, likewise. Okay, that means they are odd functions, odd inputs. We can give the odd input to give the output from Y1, Y3. Okay, and for the NAND gate, we can give 2 input. They are A and B for one input and get the output from Y1. C and D are the input to get the output from Y3, likewise. And the other gates are similar for the NAND gate. Okay, now we can perform the NOT gate first. Just assign the value as 1. You can perform 4 input. You can perform 4 gate at the same time to get the different output also. For example, we can see 1 input now. The command value I have given is 1. Apply the register values. Now go to back to schematic. I am giving the value to A and see the output from the B. To perform the logic gates, we can give for input we can take a switch. Okay, and output we can use display as well as LED also. Okay, now I am going to give the input to the A. You can see now the value is off. The switch is in off position. You get the 1. Now while on, it goes to 0. Okay, fine. You can also connect this to LED to see the values. Now it is in 0 position. Turn off to see the 1. Okay, fine. Now I am going to assign the value 2 for NAND gate. Okay, just give the command 2 to perform the NAND gate. The inputs are A and B, C, D, E, F, and G, H. Okay, we can give 2 inputs for A and B to see the output Y1. Okay, sorry. Okay, fine. Now I am going to give the inputs. Now it is in the 0 and 0. For 0, 0 we get the output as 1. You can also see the LED also. Now I am going to give 0, 1. 0, 1 is also 1. For 1, 0 is also 1. For 1, 1 it is 0. Okay, it's fine. This is for NAND gate, and these are the similar for all other gate also. You can perform other gates also in the similar way. Okay, fine. Next we are going to take a mux. Okay, just delete this. For this I am going to take a constant for input. Okay, here we have 7 input and 1 selector and output as 1 single output. Okay, now I am going to assign some values. 5, and 10. Apply the register values. I'm going to give the input 5 to the selector, and 10 the output to the number 5, number 5th input. Now you can see the output as 10. Likewise you can change any values and also give. Okay, now next one is Demux logical modules. Just delete the pins. Okay, I'm going to perform the Demux. Here I'm going to give the selector as 5 and input as 10. Okay, now we can take the output from the 5th pin. You can see the output as 5. Okay, fine. This is for Demux. You can use some other values to assign the to take the output from here. Okay, next, this is 2 input multiple output. You can see here the model extends the single input net to 4 output nets. Okay, I'm going to give the input 5 to X and 10 to Y. For each input you can take 5 outputs. I'm going to connect to display, connect all the pins. You can see for X value we have given 5, we have get 4 output as 5, and Y we have given 10 and we have get 4 input as output as 10. Likewise you can get multiple output from single input. Next one is configurable lookup table. Just right click to see the configurations. These are configuration. We are going to see about lookup table in detail in the next video. For any doubt, feel free to ask in the comment section. That's all for this video. Thank you for watching.